Hi everyone, welcome to new class. Today's class is about asynchronous inputs in the case of flip-flops. So for the clocked flip-flops like SR, D, JK and T. So in the case of SR, D, JK and T flip-flops, SR, D, JK and T inputs are called the synchronous inputs. So these are called the synchronous inputs, that is SR input, D input, J, K input and T input are called synchronous inputs. And asynchronous inputs are preset and clear. Preset and clear are called asynchronous input. So the synchronous inputs are called so because their effect on the flip-flop output is synchronized with the clock input, and these synchronous control inputs must be used in conjunction with a clock signal to trigger the flip-flop. And most IC flip-flops also have one or more asynchronous inputs, and these asynchronous inputs affect the flip-flop output independently of the synchronous input and the clock input. And these asynchronous inputs can be used to set the flip-flop to the state 1. To the state 1, that is one state, or clear. Clear means reset the flip-flop to the 0 state at any time regardless of the conditions at the other inputs. And preset and clear are the asynchronous inputs. Preset, it is denoted by PRE, also called direct set, denoted by SD, or DC set. The second one is clear, denoted by CLR, or direct reset, denoted by RD, also called DC clear. So an active level on the preset input will set the flip-flop, and an active level on the clear input will reset it. So that is in the case of active high case. So in the case of active low, that is if the asynchronous inputs are active low, then the same is indicated by a small bubble at the input terminals. So in that case, the inputs are labeled as PRE bar, that is preset bar, and clear bar. So in the case of active high inputs, if a constant 1 is held on the preset, input, then the flip-flop will remain in the Q equal to 1 state regardless of what is occurring at the other inputs. Other inputs means SR, D, JK and T inputs. Similarly, if a constant 1 is held on the clear input, then flip-flop will remain in the Q equal to 0. Q equal to 0 state regardless of what is occurring at the other inputs. And in the case of active low, that is if the asynchronous inputs are active low, so if a constant 0 to PRE, that is preset bar input, then flip-flop will remain in the 1 state, and 0, constant 0 to clear bar, then flip-flop output is 0. So this is active low case and this is active high case. And the asynchronous inputs are used to set or clear the flip-flop to the desired state by the application of a momentary pulse. And when DC set and DC reset conditions are not used in any application, then they must be held at their inactive levels. So inactive level means in the case of active high inputs, the inactive levels of preset and clear are 0. When both the inputs are preset and clear are 0 means it is in inactive state. And in the case of active low input, inactive condition, that is inactive condition of preset and clear equal to 0 for active high input, and in the case of active low, inactive condition for preset and clear are when both is equal to 1. So these are the active conditions and these are the inactive conditions for both the preset and clear in case of active high input and active low input. Let us study the preset and clear operations in detail. For JK flip-flop with active low preset and active low clear inputs, that is active low preset and clear inputs, this is logic symbol and this is truth table. So here when preset bar equal to 1 and clear bar equal to 1, that is DC set equal to 1. So when preset bar is kept 1 and clear bar is kept 1, that means clocked operation, that is synchronous operation. Synchronous operation means preset and clear have no effect on this flip-flop. Only the synchronous inputs, that is J and K, have effect on this condition, that is synchronous operation. So the asynchronous inputs are inactive. So when preset equal to 1 and clear preset bar equal to 1 and clear bar equal to 1, then the asynchronous inputs are inactive and the flip-flop responds freely to J, K and clock inputs in the normal way. And this is called synchronous operation. When preset bar equal to 0 and clear bar equal to 1. So here the DC set is activated. So Q DC set activated means this is preset, that is Q equal to 1. DC set means Q equal to 1, and it will not depend upon the synchronous inputs J, K and clock. So the clock input cannot affect the flip-flop while DC set equal to 0, that is preset bar equal to 0. And in the third case, when preset bar equal to 1 and clear bar equal to 0, that is here DC clear is activated and Q is immediately cleared to 0. That is here clear bar is activated, that is clear DC clear is activated. That means it will clear the output, that is Q equal to 0 independent of the conditions of J, K and clock input. So when preset bar equal to 1 and clear bar equal to 0, DC clear is activated, that is Q is cleared to 0. So it will depend on this inputs only, that is it will not depend on the J, K and clock inputs. So the clock input has no effect on this flip-flop when DC clear is equal to 0. And the fourth condition is when preset bar equal to 0 and clear bar equal to 0. That is when both are equal to 0. That is DC set is equal to 0 and clear equal to 0. So this condition should not be used since it can result in an invalid state. So this is about the asynchronous inputs. So asynchronous inputs are preset and clear. So in the case of active low input, when both the inputs, that is both preset and clear are equal to 1, then it is in the flip-flop is in the synchronous operation, that is the flip-flop depends on the J, K and the clock inputs, that is the normal flip-flop conditions. And when preset equal to 0 and clear equal to 1, so DC set is activated, that is the output is set. So it will not depend on the synchronous inputs J, K and clock. And when preset equal to 1 and clear equal to 0, that means the output is cleared, that is Q equal to 0. And when both the inputs are equal to 0, it is invalid case. Let us study the JK flip-flop with active, high, preset and clear inputs. So this is the logic symbol and this is the truth table. So here when both preset and clear are equal to 0, then that means clocked operation. That is the flip-flop depends on the synchronous inputs JK and clock, hence called clocked operation or synchronous operation. And when preset is equal to 0 and clear is equal to 1. That means here clear is 1. Clear 1 means the flip flop is reset. That is Q equal to 0 independent of the synchronous inputs JK and clock. And when preset 1 and clear 0, that means here DC set is 1. So the output Q equal to 1 independent of the synchronous inputs. And when both preset and clear are equal to 1, it is invalid state. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.